All right. The purpose of this video is to go over your practice midterm for you so that you have a place where it's recorded and you can see all the solutions to those problems. If you can solve all the problems on the practice midterm, you should pretty much be good for the midterm. For the practice midterm, you will be allowed to use a calculator, and on top of that, you will be allowed to use a sheet of paper of notes. So with that, just going to go through the midterm review. So starting with the first problem. Problem 1 says, express the area and perimeter of an equilateral triangle as a function of the triangle's side length x. So if we have some equilateral triangle with side length x, since it's equilateral, all the sides have the same length, x, 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 our job is to express first the perimeter, then the area as a function of x. And so the perimeter, I'll just use capital P for that, as a function of x is going to be, well, the perimeter of this equilateral triangle is obviously just that distance plus that distance plus that distance, or in other words, 3x. Okay. The next part of the problem was to express the area of this triangle as an equilateral or as a function of x. So the way I'm going to think about that is imagine splitting the triangle down the middle. I'll redraw that triangle down here. There it is. So the hypotenuse here is x. If we did that right, this would be a right angle. So I know that the Pythagorean theorem will hold for this triangle. And now half that distance is going to be exactly x halves. Now what I'm going to do is I'm going to solve for this height over here. We'll call it y for now. I'll solve for it in terms of x. And then I know that the area of this triangle is half its base times its height, and then double it to get the area of this triangle. So using our Pythagorean theorem, we know that this side squared plus this side squared equals this side squared. So x over 2 squared plus y squared is equal to x squared. We're solving for the y, so subtract this from both sides, and I get y squared is equal to x squared minus, and I'm going to just multiply it out, x times x is x squared, and 2 times 2 is 4. So we get that y squared is equal to, I have 1 x squared minus 1/4 x squared leaves me 3/4 x squared. And so now y is going to be equal to plus or minus the square root of that thing. Since it's a distance, we only care about the positive one. So the square root of 3x squared over 4, to pull the x squared out of the radical, cancels out my square there, so I just can pull an x out, and then we'll have square root of 3. I'm also going to take the square root of the bottom, that is of the 4, which is just going to be 2. And so that here is my height. Now, what is the area of this triangle right here? It's half the base times the height. So it's 1/2 the base times the height. I'm going to put the square root of 3 first. Now that is the area of this triangle. We want the area of this triangle, which is double the area of this triangle. So just multiply that by 2, or in other words, get rid of this 1/2. And now multiply it out, that fraction there. So the x times the x is going to give me an x squared. So our area function as a function of x times x is going to be x squared there. And we better get an x squared because we're calculating an area. The square root of 3 is still root 3. That doesn't change. And then finally, in the denominator, we have 2 times 2 is 4. So that is the first problem. The second problem says, in the following, one of the 3 trig functions is given, sine, cosine, or tangent. Find the other 2 if x lies in the specified interval. So this has a part A and a part B. So for part A, we are told that sine of x, remember x here is going to be an angle. Sine takes an angle and it spits out a ratio. So sine of x, it tells us, is equal to 4/5. And we know that the x, the angle, is in the interval pi halves to pi. Okay, so this is for part A. Now sine, just drawing a little triangle to the side here to help us think in general. If this is our angle theta, and we call this distance x, this distance y, and this distance r, then sine of theta is equal to y over r, or opposite over hypotenuse if you learned it that way. So that's the sides, that's the ratio that the sine of theta gives us. So over here, I know sine of our angle is equal to 4/5. So whatever the triangle is that we care about, if this is angle x, then I know that sine of that angle is 4/5, or in other words, this side is 4 and this side is 5. This will always be a right triangle. And so now we just need to find the remaining side, and then we can figure out what all three trig functions are. So again, using the Pythagorean theorem, I know this side squared plus this side squared equals this side squared. So I'll call that distance there. I don't want to use x, that will confuse you. We'll call it little a for now. So I know a squared plus 4 squared is equal to 5 squared. Subtract 16 from both sides, I get a squared is equal to 9, or a is going to be equal to plus or minus 3. So we know that's plus or minus 3. Now, I know my angle, think about our unit circle for a second here. This will tell us which one to use, the plus or the minus. My angle is between pi halves and pi. So here's pi halves, here's pi. My angle is somewhere over here. And so notice on the left-hand side, my cosine is going to be negative. So this is going to be negative 3 here, is what we want. So with that, we can now find the cosine and the tangent. So if I know sine of x is equal to 4/5, then I know cosine of x is going to be equal to, cosine of x is going to be adjacent over hypotenuse, or it's going to be the x over the r. So this is going to be equal to negative 3/5. And then the tangent, which is a slope, is just going to be equal to, you can think about as sine over cosine, which would give you 4 over negative 3, or you can think about as 4 over negative 3, rise over run. In either case, we're going to get negative 4/3. And that's finding the three tangent, or the three trig functions at that point. Now for part B gives us that the cosine of some different angle, this is now a different x, cosine of x is equal to 5/13. So once again, setting up my triangle, I know that cosine, the ratio it gives me is the x to the r, so this has to be 5, and this has to be 13. And now the only question is our triangle sticking up or is it sticking down? So I'm not sure if this is positive or negative yet. But solving for it, put a little b there. What would that little b be? I know 5 squared plus b squared equals 13, so I know 5 squared plus b squared equals 13 squared. Or in other words, 169 minus 25 is 144, b squared equals 144, or b equals plus or minus 12. And we just don't know if it's positive or negative. We just need to figure out if our sign is positive or negative on the interval, and I didn't write the interval. So this time it said x is between negative pi halves to 0. So we're doing this where x is between, sorry, that's an in symbol, is between minus pi halves and 0. So again, on our unit circle, angle minus pi halves, that's down here, and 0, that's over here. So our point, wherever it is somewhere down here. So we're at the bottom half of the circle, so our height is going to be negative. This y value right here, or b value, is going to be negative. So in our case, it's going to be minus 12. Okay, and this was our angle x, sorry. So I know cosine of x was equal to 5/13. So sine of x now, just looking at our triangle, sine just gives me the y over the r, that's just negative 12/13. And then the tangent of x, that just gives me the rise over the run, and that's negative 12/5. And that's all there is to that problem. All right, getting to notice a little bit of a jump for problem 3. The first way I did ugly. So doing problem 3 again on your practice midterm. First thing we were supposed to do is find where the function is increasing and where it's decreasing. That's part A. So here's your function h of x. we use the derivative to figure out where the function is increasing or decreasing. So taking the derivative of this, we get 4x cubed minus 4x. The derivative of the constant is just 0. We can factor the 4x out, and we are left with 4x times x squared minus 1. That's a difference of squares, so this is the same thing as 4x times x minus 1 times x plus 1. So, remember that our critical points are where our derivative is 0 or undefined. Our derivative is always defined in this case, but 0 at 0, it's 0 at 1, and it's 0 at negative 1. So, drawing out our picture here, at 0, at negative 1, and at 1 are where our derivative is 0. And now the question is it increasing or decreasing on each of these intervals? So going from negative infinity to negative 1, is our function increasing or decreasing? So we got to test a point, something like negative 2, plug in negative 2 into this. Negative 2 times 4 is a negative. Negative 2 minus 1 is a negative. Negative 2 plus 1 is a negative. So a negative times a negative times a negative is negative. So it's decreasing over here. Now let's plug in a number between negative 1 and 0. We'll say minus 1/2. Minus 1/2 times 4 is a negative. Minus 1/2 minus 1 is a negative. Minus 1/2 plus 1 is going to be positive, because 1's bigger than minus 1/2. And so negative times negative is positive. Now we'll plug in a number like positive 1/2. We get positive, negative, positive, which is going to be negative. And then plug in a number bigger than 1, like 2, and we get positive, positive, positive is going to be positive. So our function is decreasing, increases, decreases, increases. And so at negative 1 and 1, it's going to have a local min, it's going to have an absolute min and a local min at each of those points. But this function is not going to have any absolute max. It's going to be coming down, go up, come down, and then shoot back up to infinity. So just get a rough idea of what this function would look like. Help us think about it. At 0, what is our function at 0? That's 6. So our function is right there. At negative 1, when I plug negative 1 into this, we get 1 minus 2 is negative 1, plus 6 is 5. So over here at negative 1, we're up at 5. And then over here at positive 1, we get 5 again. And so our function is going to look very roughly like this. So it has an absolute min. So let's finish this part. So it's increasing on the intervals, increasing from negative 1 to 0, and increasing from 1 to infinity. It's decreasing on the intervals negative infinity to negative 1, and on the interval 0 to 1. Okay, absolute and local mins are max. It has absolute min at x equal negative 1 and at x equal 1. Those are the two places where we get an absolute min. Now this function doesn't have an absolute max, but it has a local max at 0. So then we have a local max at x equal to 0. And that is problem 3. Problem 4 says, let f of x equal the square root of x plus 1. So f of x is equal to the square root of x plus 1. And we have g of x is equal to 1 over x plus 4, I believe. And h of x is equal to just 1 over x. Okay, so for part A, we are supposed to write the formula for f composed with g composed with h. So f composed with g composed with h of x. So what does that equal? Now, this is the same thing as f of g of h of x. So we kind of work this problem backwards. First, we're going to take h of x and plug it into g of x. Then we're going to take that result and plug it into f of x. So this is f of g of h of x is just 1 over x. So now we're going to plug 1 over x into this. So that's going to be f of, well, let's see what g of 1 over x is. So g of 1 over x is going to be 1 over x plus 4. I'm going to multiply this term top and bottom by 4. Oops, sorry, no. I'm going to multiply this term top and bottom by x. So this is 1 over x plus 4x over x. So I get a common denominator in the denominator. So that is 1 over 1 plus 4x all over x. And now, dividing by a fraction is the same thing as multiplying by its reciprocal. So this is equal to x over 1 plus 4x. Okay, so that is g of h of x, g of h of x. What we want now is to find f of g of h of x. Or in other words, we want to find f of this whole thing, x over 1 plus 4x. What does that equal? So plugging this in for the x there, that is just going to be the square root of whatever we're plugging in plus 1. Whatever we're plugging in plus 1. Now I'm going to take that 1 and I'm going to multiply it top and bottom by 1 plus 4x to get a common denominator. And so this is going to be equal to the square root of, over here we're going to have an x plus, let's see, our numerator over here now is going to be 1 times 1 is just 1, plus 1 times 4x is just 4x, and we got a common denominator now, so our common denominator is just 1 plus 4x, or 4x plus 1, just swapping the order I write those, doesn't matter. And now finally, x plus 4x is 5x, so we got square root of 5x plus 1 all over 4x plus 1. Okay, so there is f of g of h of x. It's that formula right there. You have to go through all the simplifying work. You can't just leave it unsimplified. Okay, so now part B. This time, we are supposed to find h composed with g composed with f of x, which is going to be h of g of f of x. Now, f of x is just square root of x plus 1, so this is h of g of the square root of x plus 1. Plug that in for g. G is just 1 over x plus 4. So this is h of, plugging this in for g, we get 1 over the square root of x plus 1 plus 4. And now, we need to take that and plug it into h. H is just a reciprocal function. Whatever you plug in, it spits out the reciprocal. So h is just going to spit out the reciprocal of this, which is just going to be the square root of x plus 1 plus 4. So that is how we do part A and B for problem 4. Scrolling down now to problem 5. Okay, problem 5 wants us to prove a particular limit. This is something that you're going to want to have written on your note card, is the definition of a limit. So what exactly, well, let's write out the problem. The problem says, it asks us to prove that the limit as x approaches 3 of 2x minus 4 is equal to 2. Now we have to prove this using the actual definition of a limit. So what does it mean to say that the limit as x approaches c of f of x is equal to L? What exactly does that mean to say that the limit as x approaches some number of some functions equals some limiting value? Remember that by definition, this meant that for any positive number epsilon, we have to show that there exists some other positive number delta, such that if the distance between x and c is less than delta, then that implies that the distance between f of x and L is less than epsilon. Going back pretty early in our calculus material. So in our concrete case, our c here is going to be 3. So I'm trying to prove that the limit as x approaches 3 of f of x, so our f of x is this. I'm trying to show that that equals 2, so our L is 2. I know that I'll have done that if I can show that for any epsilon, there exists a delta such that if the absolute value of x minus, remember our c is 3 here, is less than delta, that implies that the absolute value of 2x minus 4, there's our f of x, 2x minus 4, minus our limiting value 2 is less than epsilon. Okay, so with that in mind, let's start our proof. So 1, we need to start with let epsilon greater than 0 be given. So you get to choose any positive number epsilon you want. My job is to find the delta that makes this over here true. Now, it's typical that we do some scratch work to the side to kind of reverse engineer what we want this delta to be. We probably plug it in here. So observe that the absolute value of f of x minus L, maybe I'll write that out to be a little bit explicit, is equal to, I'll go down another line so we don't extend it to our definition there, is equal to 2x minus 4 minus 2, which is equal to the absolute value of 2x minus 6, which is equal to, factor 2 out of it, 2 times the absolute value of x minus 3. So notice, if x minus 3 is less than delta, I want 2 times x minus 3 in the absolute value to be less than epsilon. That's what I'm after here, so maybe you can just see it. We want to let delta equal 1/2 of whatever our epsilon is. So let epsilon be any number, we're going to choose delta to be half of that. So then notice what happens. We need to show that if this is the case, then this is the case. So assume that the absolute value of x minus c, in our case 3, is less than delta. What does that give me? Well, that gives me that the absolute value of x minus 3 is less than epsilon halves, because delta is the same thing as epsilon halves. Multiply both sides by 2, so that gives me that 2 times x minus 3 is less than epsilon. So notice that I found a delta such that if the absolute value of x minus 3 is less than delta, then the absolute value of f of x minus L is less than epsilon. Let me just rewrite this one more way. Notice that this was the exact same thing as f of x minus L. So I have f of x minus L is less than epsilon. That's exactly what that is. So if x minus 3 is less than delta, then f of x minus 2, I guess we could keep it how we had it, and write our actual concrete function. Maybe put parentheses here to show us the substitution very explicitly. 2x minus 4 minus 2 is less than epsilon. So that's all there is to it. For any epsilon you choose, there is a delta that demonstrates this limit. Okay. Next one, we're going to let f of x be some function. So it says let f of x equal the sine of x minus sine of x. And it says to find the limit as x approaches pi of f of x. So we are looking for the limit as x approaches pi of f of x. Okay, what did it mean for a function to be continuous? Another thing that's worth having on your card. F is continuous at c if and only if what is a condition. It means that the limit as x approaches c of f of x is equal to f of c. Or in other words, the limit of the function at the point is equal to the value of the function at the point. That's what it means to be continuous. Now, we can already use the fact that I know that x by itself, just polynomial, is continuous. We know that sine is continuous. We know that the difference of continuous functions is continuous. And then we know that function composition preserves continuity. So passing a function into a function, if both the functions are continuous, preserves continuity. So I know that this is a continuous function. What does that mean? That means the limit as x approaches pi of f of x is just equal to f of pi, which in this case is equal to, plug in the pi, so we get sine of pi minus sine of pi, maybe put parentheses there. Sine of pi is just 0, so this is equal to sine of pi, which is just equal to 0. So that is the limit of this function as x approaches pi. And we were supposed to determine if the function f is continuous at pi. The answer is yes, the function f is continuous everywhere, but yes, it's continuous at pi as well. Okay, next problem, problem 7. Problem 7 says to find a limit, so we don't need to do a proof here, we just need to find the number. So we're looking for the limit as x approaches, that's a -3, -3 of 2 minus the square root of x squared minus 5 all over x plus 3. Okay. So notice that we can't just plug in -3 like we did on the previous problem. If I just plug in -3 to this, we're going to be dividing by 0, and that's going to break our function. So we can't just plug in this -3 because we have this in the denominator. So our whole goal here is to rewrite this function in a way that we can cancel out that x plus 3. So I need somehow for an x plus 3 to show up in the numerator, that way I can cross cancel, and then I can plug in my -3. So right now this factor is stopping me from plugging in -3. Now, very standard, when you have a radical in an expression that you're trying to simplify, is to multiply top and bottom by the conjugate. So I'm going to multiply by the conjugate of this thing. What's the conjugate? It's just switch that sign, and that's the conjugate. Now, I can't change my expression, so if I multiply the top by that, I have to multiply the bottom by that. Now, what does that give us? In the numerator, the 2 times the 2 gives us the 4. We're going to have, so I did the 2 to there. The negative square root of x squared minus 5 to 2 is going to give us -2 of those square roots. And then the 2 to the positive radical here is going to give us +2 of those square roots, and those cancel out. And then finally, the negative radical times the positive radical is going to give me negative, just to be super explicit, it's going to be negative x squared minus 5 all squared. Taking that and multiplying it by that. And squaring the radical just gets rid of the radical. So we can get rid of that, and just write it like this. Keep our parentheses so we don't forget to distribute our negative. And then in the denominator, do not bother trying to multiply that out because we're going to ultimately try canceling out this x plus 3. So don't distribute it through. Just write it as x plus 3 times whatever we had over here. Times 2 plus the square root of x squared minus 5. And leave it like that. Okay. I'm trying to get an x plus 3 to show up in the numerator so I can cross cancel. So let's work that out and see if we can factor. We're taking the limit of this whole thing, so it's not really equal to that, just the inside part is equal. Okay, up here, we have a negative x squared, and then a negative 5 is a positive 5 to the 4 is plus 9. All over all this same stuff. Won't bother rewriting that out. Okay, now that is equal to, factor out the negative. We could work with it already, but it's usually easier to just factor the negative out from your highest power term before you factor. So I'll pull the negative out front. Since I pulled a negative out of x squared, I'm left with x squared positive. And since I pulled a negative out of that, that's now a -9. All over, still same denominator. Notice if I multiply that negative back in, we get the negative x squared, and negative times negative is positive 9, so we haven't changed it. Okay, now, how can I factor this? So I have our negative sign. We need to find two things that, well, it's just a difference of squares, maybe you can just see that. Or we need to find two numbers that add together to be 0 and multiply together to be -9, and that is going to be +3 and -3. This time we'll bother, I'm slanting a lot, it's hideous. So this is negative, we had x plus 3, x minus 3, all over. Now in our denominator, I'm going to bother rewriting it out now. X plus 3 times 2 plus the square root of x squared minus 5. And now, as we were after this whole time, we can cancel out this x plus 3 top and bottom. And so this is all equal to, we still are taking our limit, this is the limit as x approaches minus 3 of, we now have x minus 3 all over 2 plus the square root of x squared minus 5. And our whole goal there was to get rid of that x plus 3 so that we could just plug in this negative 3 number. So notice now plugging in negative 3 doesn't break the function and we're good to go. So this is going to be equal to, just plug in the negative 3 now. Negative 3 minus 3 is negative 6. All over 2 plus, in the denominator we have, negative 3 squared is 9, minus 5 is 4, the square root of 4 is 2. Or in other words, we have negative 6 over 4, or in other words, we have negative 3 halves. And there's our answer. That's the limit of this function as x approaches negative 3. Moving on to problem 8 now. We're going to be finding the slope of some function. Let's see. So we're given some function f of x is equal to x plus 2x squared, if I'm reading that right. X plus 2x squared, yes. So we're supposed to find the slope of the function at the point 1, 3. So the point we care about is the point 1, 3, when x is 1, y is 3. Then we want to find the equation for the line tangent to the graph at the given point. So whatever this function looks like, I don't know, something. At 1, 3, our job is to find the equation of the tangent line through that point. That's what we're trying to do. So first off, we need to find the slope of the function at that point. That's what our derivative gives us. So f prime of x is equal to, I'm going to write this term first. Bring down the 2 gives us 4x plus 1. So what is the slope of our function at the point 1, 3? Well, just plug in our x value. And so our slope at 1 is equal to 5. Now, the equation of a line that goes through a point and has a particular slope, so this is going to be our slope, that's our m. The equation of a line that goes through a point and has a particular slope is y minus y1 is equal to m times x minus x1. Another formula you'll want to have on your card. And now we get that y, solving for y really quick, is equal to m, which is 5, times x minus, our x1 is the x coordinate we care about, plus y1, our y coordinate there, is 3. Keep messing with this, and we're going to get 5x. 5 times negative 1 is negative 5, plus the 3 is going to be minus 2. So y is equal to 5x minus 2 is our tangent line. Find the equation for the tangent line of the graph at the point. Yep, that's all we're doing. Let me... see here. 5x minus 2. Just making sure I got the same answer. Okay. So our next problem is we're told some function z. So I'm told that z is equal to 1 over the square root of w squared plus w. Our job now is to find the derivative of z with respect to w. What does that equal? Okay, let's rewrite z here in a way that's a little bit easier for us to reason about. Remember that an exponent being at the bottom is the same as making it negative to bring it to the top. So this is the same thing as w squared plus w to the negative 1/2. 1/2 for the radical, negative because it's downstairs, not upstairs. And now we can just use our chain rule, basically, the derivative of the outside times the derivative of the inside. So bring down the minus 1/2, we get minus 1/2 times w squared plus w, whatever we had, subtract 1 from it, so now we get to the minus 3/2. And now we're doing the chain rule, so multiply by the derivative of the inside. What is the derivative of the inside? Well, that's going to be 2w plus 1. Okay, so this is equal to, we'll put the negative out front. This whole thing is going downstairs. The 2's downstairs times this whole thing. We have the w squared plus w to the 3/2. And then in the numerator, we have the 2w plus 1. Let me double check what I got. Negative 2w plus 1 over 2 times w squared plus w all to 3/2. Yep, looks like we did, right? Okay. Next one, we're supposed to find the first and second derivative of some function. So we're told y is equal to negative x cubed minus 7 all over x. And so we need to find the first and second derivative of y with respect to x. So we could write dy dx, or that's the same thing as y prime. So taking the derivative of this, we could do a quotient rule, the derivative of the top, or the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Or maybe it'd be easier to think about splitting this up into 2 separate fractions. So splitting it up into negative x cubed over x, which is negative x squared, minus 7 over x. And then just to really help us take the derivative, I may write it one more way. That's negative x squared minus 7 times x to the negative 1. Okay, so taking our derivative now, derivative of this, we get negative 2x minus, bring down the negative 1 makes it plus, 7 times x to the minus 2. So there's our first derivative. Our second derivative is equal to, take the derivative of this, we get negative 2. The derivative of this, bring down the negative 2, gives us a minus 14 x to the negative 3. Now, just rewriting each of these out, this would be negative 2x plus 7 over x squared. And this would be equal to negative 2 minus 14 over x cubed. See how I decided to write that final answer. I left it like that. If you wanted to recombine those with the common denominator, that would be perfectly fine too. I'll give you full credit either way for a problem like that. Okay, so for our next problem, we are just given some function r, and we need to find its derivative with respect to theta. So we're told that r is equal to 4 minus theta, that is a cubed, times sine of 2 theta. Okay, we're looking for dr d theta, the derivative of r with respect to theta. The 4 here, that's just a constant, so we can ignore that. So we just need to take the derivative of this thing. Notice that we have a product of 2 expressions that have theta showing up in it. So this is going to be a product rule. What is our product rule? Another good formula for you to have written, which is the derivative with respect to x of u times v is equal to u times v prime plus v times u prime. The first times the derivative of the second plus the second times the derivative of the first. So I'm going to think about r, let me just write it one more time. I'm going to think about negative theta cubed as my first times my sine of 2 theta as my second, and then just plus 4, we'll ignore that and take our derivative. Okay, so dr d theta, or r prime, same thing, r prime is equal to, we're going to do the first times the derivative of the second. The derivative of the second, be careful, we have a chain rule here. So the derivative of sine is cosine, and we still have whatever the inside was, and then times the derivative of the inside is 2. So that was the first times the derivative of the second. Now we need to add that to the second times the derivative of the first. I'll do the derivative of the first. first, so I'm going to write the u prime and then I'll write times that. So the derivative of this is negative 3 theta squared and then times sine of 2 theta. Now some simplifying. This is just equal to, bring the 2 out front, so we have negative 2 theta cubed times the cosine of 2 theta. Over here we have minus 3 theta squared times sine of 2 theta. Let's see the answer I wrote this one first. Negative 3 theta squared times sine of 2 theta minus 2 theta cubed times cosine of 2 theta. Okay, same thing. All right, so for our next problem, we are given a function and told to find its slope at 2 points. For this problem, we're going to have to use what we call implicit differentiation, where we take the derivative of both sides of the function at the same time, rather than trying to solve our function in terms of y and then take the derivative. So I have y squared plus x squared. Y squared plus x squared is equal to y to the 4 minus 2x. And my job is to find the slope at the points negative 2, 1, comma, and negative 2, negative 1. So whatever this function looks like, I have no idea. Notice it's not even a function, because for the same input we get 2 different outputs, so it could be some circular shape, some blob-like shape, I don't know. But we know that at negative 2, it has a height, not to scale, pretend that's negative 2, it has a height of both 1 and both negative 1 down here. And so we need to find the slope here of the function and the slope here of the function, whatever it looks like. Okay. So the way that we're going to do this is just implicit differentiation. We're just going to take the derivative of both sides. If this thing is equal to that thing, then this thing's derivative is equal to that thing's derivative. Now we're taking the derivative with respect to x of both sides. So what is the derivative of y squared with respect to x? So that's going to be 2 times y, and then the chain rule times the derivative of y with respect to x, which we usually write as y prime. Plus, this one is 2 times x times the derivative of x with respect to x, which is just 1, which is why we get a y prime here, but we don't get an x prime here. X prime in this context would just be 1. Okay, so this is equal to, bring down the 4 times y cubed, again chain rule, times y prime, minus 2 times, bring down the 1, that's times x to 0, so just negative 2 times dx is just 1. So it's just like that. Okay, we want to find the slope. Remember, y prime is what gives us our slope. It gives us our rise over our run. So we're now going to solve this expression for y prime. So I'm going to put all my terms that have a y prime in them on this side and everything else on that side. So I'll put my y terms over here and then everything else over there. So on this side, we're going to still have our 2x, and then we'll have our plus 2, bringing that over, is equal to, on this side, we're going to have 4y cubed times y prime minus 2y times y prime. Now, I'm going to factor the y prime out of this side, and now I'm going to swap the order that I write in. So factoring out a y prime times 4y cubed minus 2y, that's writing this side, just factored out the y prime from each term, is equal to 2x plus 2. Now finally divide both sides by this thing, and I'm left with y prime is equal to 2x plus 2 all over 4y cubed minus 2y. So this gives me the slope of our function at any point xy. Plug in your x's and your y's and it gives you the slope. We were looking for it at these 2 points. So what is y prime? Y prime, what is the slope evaluated at the point negative 2, 1 equal to? Well, plug in negative 2 up here, and so we're going to get 2 times negative 2 is negative 4, plus 2 is negative 2. All over in the denominator, we're plugging in a 1 for our y, So we're getting 4 minus 2 is just 2. So negative 2 over 2 is just negative 1 is our slope there. And what is our slope evaluated at the point negative 2, negative 1? Our numerator will still just be negative 2 because we're plugging in the same x, so we just need to find our denominator. This time we're plugging in a negative 1 for our y. Negative 1 cubed is negative 1, times 4 is negative 4, so we have negative 4. And then we have subtract 2 times negative 1 is plus 2. And so it's going to be negative 2 over negative 2, which is going to be positive 1. So this is going to be positive 1. Take the time to check that. Yes, that looks correct. Okay. Problem 13. Somewhat similar problem. For problem 13, we're given some function x squared plus y squared equals 25. So x squared plus y squared equals 25. That's a circle centered at the origin with radius 5. And we're told that the derivative of x with respect to t, notice that t isn't a variable that shows up in there. The derivative of x with respect to t is equal to 2. We are looking for dy dt. It says what is dy dt equal to, so this is what we're trying to solve for, when x equals 3 and y equals negative 4. When x equals 3 and y equals negative 4. Okay. And how can we think about this function? You can think about this as we're looking at a particle moving around in a circle of radius 5, and x is some function in terms of t, which tells us the x position of the particle at any time t, and y is also some different function in terms of t, which gives us the y coordinate at any time t, as this particle moves around in a circle. That's one way to think about it. And so dx dt is how the x position is changing with time, and dy dt is how the y position is changing with time. So at x equal 3, y equal negative 4, that's going to be somewhere over here. We are looking for how the height is changing with respect to time, how the particle is moving upwards is a way to think about it. Anyways, even without thinking about it, we can just brute force calculate this. We're looking for dy dt, and so we're going to differentiate the sink, both sides with respect to t. And so what is the derivative of x with respect to t? This is going to be 2x times. Now we're taking our derivative with respect to t this time, not with respect to x. So it's not 2x times dx dx, that's what we normally do, which turns out to be 1. But this time it's 2x times dx dt. And then we have plus, the derivative of this is going to be 2 times y times dy dt. Is equal to, the derivative of a constant is 0. We're trying to solve for dy dt, so I'm going to move that to the other side. So I get 2y times dy dt is equal to negative 2x times dx dt. I get dy dt is equal to negative 2x times dx dt all over 2y. And now we know what all these values are, so we can get our number. X, we were told, is 3, so we got negative 2 times 3 times dx dt is 2, all over 2 times our y was negative 4. So this is equal to, in the numerator, we have minus 12, and in the denominator, we have minus 8. Cancel out a negative 4 top and bottom, and we're left with 3/2. Let me double check that. 3/2 is what I got. Okay, so there is our answer. Moving on to the next problem, problem 14. We're looking for inflection points and the maximum and minimum of some function. Okay, so our function is y equals x plus 2 cubed y equals x plus 2 cubed minus 1. And identify inflection points, local max, local min, and identify the intervals on which the function is concave up and concave down. Okay, so we're definitely going to need y prime, the derivative of this. That's just going to be 3 times x plus 2 squared, chain rule times 1, but we don't care about that. So that chain rule would just give us times 1. So we can leave that off. And then taking the derivative again, that is going to give us 6 times x plus 2 now to the power of 1. Okay. We are looking for local max and local min. Those can only happen at critical points where our derivative is 0 or undefined. And in this case, our derivative is only 0 at -2. -2 is the only number I can plug in there to make my derivative 0. Now take a number a little bit to the left of -2, so plug in something like -3. We get -3 plus 2 is -1, squared becomes positive, times 3 is positive. Similarly, plug in a positive number, or plug in something like -1. -1 plus 2 is 1, squared is positive, times 3 is positive. So this function is constantly increasing. So whatever it looks like, it cannot have any local max or any local min or absolute max or absolute min, because its only critical point, the function keeps increasing through it. So there's no hill, there's no bump up or bump down. Okay. Next, we have, where is it concave up? Or, let's see, were we supposed to say where it's increasing or decreasing? Identify inflection points and local max and local min. No, just where it's concave up and concave down. So now, where is the second derivative 0? So the second derivative is 0 at -2 again. And now, the plus and minus here are going to mean concave up or concave down, not increasing or decreasing. So look to the left of -2, so plug in something like -3. -3 plus 2 is -1 times 6 is a negative number, so it's concave down over here. Plug in a positive number, or something to the right of -2, like -1. -1 plus 2 is positive, 1 times 6 is going to be positive. And so it is concave down on the interval -infinity to -2, and it is concave up on the interval -2 to infinity. And what this function will look like very roughly. Let's see, when we plug in -2, we get 0, subtract 1 is -1. So when we plug in -2, we get -1 like that. And then this function, it's constantly increasing, but concave down to the left-hand side. So concave down, that's like a frowny face. So the increasing half of a frowny face, something like this. And then we're concave up over here and still increasing. So the increasing part of a smiley face, something like that. And yeah, it's just a cubic function, shift 2 units. Oh, oops, that was supposed to be a -2. My bad. -2, -1. So, like this. And yeah, it's just a cubic function, shift 2 units to the left, 1 unit down. Okay. So there's that problem. Problem 15, we're asked to design a half-liter can that has the shape of a right circular cylinder. So half liters is 500 cubic centimeters. So we're designing some can here. That's meant to be a right cylinder. It's going to have some radius r, it's going to have some height h, and we know that we want the volume of this thing to be half a liter, or in other words 500 centimeters cubed. Our job is to find the dimensions that will minimize the surface area, minimize the amount of material used. So first off, we also want the volume of a cone, or sorry, of a cylinder is the area of the base times the height. So the area of a circle is pi r squared times the height. Okay, now our function for the surface area of the sink, we have the area of this circle plus the area on the bottom. So that's 2 pi r squared plus the area of the part that wraps around the can. So that's going to be if you imagine unrolling it, that would give us this flat sheet that would have a height of h, and the top here would be whatever the circumference of that circle was, so 2 pi r times h. So add that one, 2 pi r times h. And we're adding together two areas, so we better have an r squared here and an r times an h there, so we're going to get units squared, each one for the area. And for this one, a square times a 1 is going to be a cube for the volume, so all our units make sense. Okay, so now we're trying to minimize the area. Whatever this area function looks like, I don't know, but it's going to do something like, maybe something like that, and it's going to have some minimum here where the derivative is 0, so we're going to look at where the change in the area is 0. If this was applying the area function for all r. Now we can't take the derivative of it yet because we have two variables, r and h. If we're going to take the derivative, we need to write this in terms of one variable, r, or in terms of one variable, h. Looking at our, combining these two together, notice that they give us that we want pi r squared times h to equal 500, or in other words, we want h to equal 500 over pi r squared. And now we'll substitute that h in right here, and then we'll have our area only in terms of r's. So area is going to equal 2 pi r squared plus 2 pi r times h, 500 over pi r squared. Now we'll cancel out this pi, maybe use a red to help see it. We'll cancel out this pi with this pi. We'll cancel out one of our r's, leaving 1 with that r, and so this will simplify to, we have 2 pi r squared plus 2 times 500 is 1,000 all over r squared. Or since we know we're going to be taking a derivative, I'm just going to write it as 1,000 times r to the minus 2, just to help us take the derivative. So now our derivative of a with respect to r, which I'll call a prime, is going to be equal to 4 pi r minus 2,000 times r to the minus 3. And now we want to know where this is equal to 0. So I want to know where that is equal to 0. That's where I'll have a local min. So I'll move that to the other side. We've got 4 pi r is equal to 2,000 times r to the minus 3. We'll write it as r over r cubed like this. So just move that to the opposite side, but wrote this one first for some reason. Now multiply both sides by r cubed and divide both sides by 4 pi. So we're going to get r to the 4 is equal to 2,000 over 4 pi, which is going to be equal to 2,000 divided by 4 is just going to be 500 over pi. Did I do all that right? Now here's my mistake. When I canceled out this r, there was only 1 left. So this was times r to the minus 1. So 2 times 500 was 1,000, and we only had 1 r in the denominator. So now when we take its derivative, bring down the negative, keeps it 1,000. Negative 1 times that to the negative 2. So now when we move that to the other side, this would have been a 1,000 times an r squared. And now this would be an r cubed is equal to 1,000 over 4 pi. So multiplying both sides by r squared and dividing both sides by 4 pi, which is the same thing as 1,000 divided by 4 is 250 over pi, which is equal to the cubed root of 250 over pi. So that is, oh, sorry. That's what r will equal. So r cubed equals that. So our r is going to equal the cubed root of 250 over pi, and that will be approximately, if you plug that into your calculator, my calculator will turn on. See if I can get a little more juice out of those batteries before they die. Okay, that's working. So we were looking at 250 divided by pi, all in parentheses, raised to the power of 1/3, gives us roughly 4.3 centimeters. 4.3 centimeters. And then if you take this r and you plug it back in to get h, you're going to find out that h is equal to exactly to r, which will be approximately 8.6 centimeters. Okay, there's that one. Next problem, problem 16, is using Newton's method. So Newton's method, once again, probably one you're going to want on your formula. Remember that our approximation at our next point is equal to our approximation at our previous point minus, let me make sure I don't just write it wrong, minus the value of the function at our previous point over the derivative of our function at the previous point. Okay, so that's Newton's method, and we are using Newton's method to approximate the square root of, oh, I have a typo here. I say approximate the square root of 7 from the function f of x is equal to x squared minus 11. We'll pretend that we're looking to approximate the square root of 11 instead of 7. I'll make sure not to have a typo like that on the test. So pretend that the problem says that we're trying to approximate the square root of 11 using the function f of x is equal to x squared minus 11. The value of x that makes this function 0 is the square root of 11, so that's what we'll be using. And we're going to start with our first guess. I tell you what it is, you don't get to choose. Since I'm letting you use a calculator on the test, I want to make sure you know how to use Newton's method. So I tell you that our first guess is going to be 3, and I want you to find what our third approximate value for the square root of 11 would be. Okay, so we'll guess that the square root of 11 is approximately 3, not a bad guess. So then what is x of 1 going to be? Why did I erase it? So Newton's method is equal to our next guess is equal to our previous guess minus the value of the function at our previous guess over the derivative of our function at our previous guess. Notice that we're going to be using the derivative over and over again. So let's really quick find the derivative of our function. That is just going to be 2x. Okay, so x of 0 is equal to 3. Now what's x of 1 equal to? X of 1 is equal to x of 0, which in our case is 3, minus f of 3, all over f prime of 3. Just plugging directly into that formula. And so this is equal to 3 minus 9 minus 11 is negative 2 over 6, which is equal to 3 minus a minus is plus 2 6 is the same thing as 1/3. Or in other words, 3/3 plus, not 3/3, 9/3, 3 is 9/3, multiply top and bottom by 3. 9/3 plus 1/3 is 10/3. So 10/3 is our second approximate guess for the square root of 11. Now, let's find our next guess. Our next guess is equal to our previous guess minus f at our previous guess divided by f prime at our previous guess, which is equal to 10/3 minus plugging in 10/3 up here. So we got 100/9 minus 11 in terms of ninths is going to be 99/9, or in other words 11, all over. In our denominator, we're going to have 2 times 10/3 is 20/3. And this is going to be equal to 10/3 minus, in our numerator, 100/9 minus 99/9 is 1/9. All divided by 20/3. When you divide by a fraction, you multiply by the reciprocal. So this is equal to 10/3 minus 1/9 times 3/20ths, which is equal to 10/3 minus a 3 and a 3 cancel out, so we're left with a 1/60, which is going to be, let's see, convert this into, how's the best way to do that? Get this in terms of 60ths, I need to multiply it by 20, so 10 times 20, I'm multiplying this top and bottom by 20. So that's going to be 200/60 minus 1/60 is equal to 199/60 is our approximation for the square root of 11. Calculator died on me again. Not sure if I can trick it again. Maybe. Okay, so 199 divided by 60. Oh, it reset. So 199 divided by 60 is approximately, this comes out to approximately 3.31667. And then when we look at the actual square root of 11, the actual square root of 11 is approximately 3.31662. So you can see after just a couple iterations, it gave us an amazing approximation for the square root of 11. All right, next problem. Again, this is not a problem that you should know how to do. Part B and C, those were an accident. Should not have given you that, so just part A is all you have to do. And you only have a problem like part A on your actual midterm. So, it asks us to find the antiderivative. Find an antiderivative. So we don't need to find all the families, we just need to find one particular antiderivative of our function f of x is equal to x to the minus 4 plus 2x squared plus 3. So then the antiderivative of that, I'll mark it as a capital F of x, is going to be equal to, this time we add 1 to the exponent, then divide. So negative 4 plus 1 is going to be x to the negative 3, and then we divide by negative 3, plus 2 times x cubed over 3, plus 3x plus, we only need to find a particular, not the family, so I could put a c there, that would be all the antiderivatives, but we just need a particular one, so I'll pick a value for c, I'll pick c to be 0. So there is an antiderivative of that function. And just write it a little bit nicer, here's the way I have my answer written. So I wrote it as negative 1 over 3x cubed plus 2x cubed over 3 plus 3x. Just cleaning up a little bit right there. Okay. Problem 18 now. So 18 tells us the derivative of a function, and we need to find the function it's the derivative of, the antiderivative. So it says, suppose that f prime of x is equal to 2x plus 1, and that Oh, that's it. So now, for part A, well, for each part, our job is to find f of 3. What does f of 3 equal? That's what we're trying to figure out, given what the derivative is. In part A, we need a little bit more information in each case. So in part A, what's given to us is that f of 0 is equal to 2. Now, in general, what is the antiderivative of this? Remember, add 1 to the exponent. You can think about the exponent there as being 1. So add 1, then divide. So I'll write big F for it. We know that big F is going to be, add 1 gives us 2, divide, cancels out the 2 there. It's going to be x squared plus x plus a constant. So the antiderivative has to be of this form. We're looking for, sorry, this is just F now, because here's F prime, so here's F. Now I'm looking for f of 3, given that f of 0 equals 2. So notice that if f of 0 equals 2, that tells me c has to be 2. When I plug in 0 to f, in case A, then the result is 2. So that tells me that c is 2. So then what is f of 3 if c is 2? So in this case, I know that my function f of x is equal to x squared plus x plus 2. And so f of 3 in this particular case is equal to 9 plus 3 is 12 plus 2 is 14. For part B, I am told that f of 1 is equal to 0. So now I know that when I plug 1 into this function, I get 0. So 1 plus c has to be 0. So 2 plus c has to be 0, or in other words, c has to be negative 2. So in this case, f of x, I know is equal to x squared plus x minus 2. So now when I plug in 1, I get 0. And so in this case, what is f of 3 equal to? 9 plus 3 is 12, minus 2 is 10. And then for part C, I'm told that f of 0 is equal to 4. So if f of 0 is equal to 4, then c has to be 4. So in that case, our f of x is equal to x squared plus x minus 2. And so f of 3 in that case is just going to be 9 plus 3 is 12. I wrote minus 2, but I said plus 4, I think. I meant to. So 12 plus 4 is 16. So should have gotten 14, 10, and 16. And then finally, for problem 19. Problem 19 says to just find an antiderivative. So find an integral. Find the indefinite integral of the square root of x, plus 2x cubed with respect to x. So that is going to be equal to, remember that x squared, remember that square root of x is the same thing as x to the 1/2 to help us think about it. So taking the antiderivative, just add 1. So 1/2 plus 1 is 3/2, and then dividing by 3/2 is the same thing as multiplying by 2/3. So that's 2/3 times x to the 3/2, plus adding 1 to 3 is 4, dividing by 4, 2 over 4 is the same as 1 over 2, so that's x to the 4 over 2, plus some constant. For problem 19, and then for problem 20, it says find the integral of negative tangent of x times secant of x with respect to x. Now notice we've already determined that tangent of x times secant of x is the derivative of secant of x. So its antiderivative is just secant of x, and then the negative makes it negative. So it's just going to be equal to negative secant of x plus some constant. In other words, take the derivative of that. Negative is a negative. The derivative of secant of x is just tangent of x times secant of x. So there's its antiderivative. That's for problem 20. And that is our entire midterm. I know I messed up on one of the problems. I accidentally got the signs wrong. I noticed that after a little bit. Hopefully I remember to correct that in the YouTube video with a little note card. But there's the practice midterm. There's all the problems on it. If you know how to do all those problems, you should be great for your midterm. The midterm should be roughly the exact same size as this. I don't know, it took me an hour and a half to get through it. I don't know. You have the link on the video. So that gives you a sense for how long it could take. I typically like to give you enough time to solve each problem twice. Anyways, there you go.